Hope you all are safe at home. This week also we are continuing with the chapter Redox reactions and rate of chemical reaction. In the last class we discussed about how we can define oxidation and reduction in a different way, isn't it? By which when the oxidation number is increasing, it is oxidation, and when the oxidation number is decreasing, it is reduction. Isn't it? I hope you all remember about it. Please try to revise the things which we have studied in the earlier classes, because if you don't revise what we have studied in the earlier chapters, it will be difficult for you to follow the next continuous classes. Today we are going to find out the oxidation number. How to find out the oxidation number? Okay, so we will see one example here which is given in your text itself. Okay, first one, I have written a form H2SO4. Okay, you know what is this, isn't it? What is it? Yeah, sulfuric acid. So the question is how to determine the oxidation number of sulfur here, isn't it? Yeah, how to determine the oxidation number of sulfur here. Okay, so sulfur is the one that we have to find out. Sulfur. But we have given the oxidation number of hydrogen. Hydrogen oxidation number plus 1. Oxygen oxidation number -2 is given. So when the oxidation numbers of other things are given here, how are you going to find out the oxidation number of sulfur? So in maths, isn't it, when you are studying equations, what will you do? If you find area is given, breadth is given, you have to find out the length, isn't it? So what will you write first? Let the number be x. Okay, let the length be x, isn't it? You are first writing like that, and then you are solving that equation. Same method. We are using little bit of maths here. I hope you all know to divide, subtract, multiply, etc. No confusions in that. Okay, then. So let the oxidation number of sulfur be x. Okay, let the oxidation number, I have written as oxidation number. Okay, the oxidation number of sulfur is what we have to find out. Sulfur be x. Okay. Next one. Here, how many hydrogen atoms are here? 2 hydrogen atoms are here. What is the charge here? Plus 1, isn't it? Plus 1 and -2. Okay. Since there are 2 hydrogen atoms, the whole charge of hydrogen will be plus 2. Okay. The whole charge of hydrogen will be plus 2. There is plus 1 into 2. Okay. That is plus 2. Plus oxidation number of sulfur, we don't know. It's plus. Here, the oxidation number of one oxygen atom. Okay, please listen carefully. The oxidation number of one oxygen atom is -2. So, if the oxidation number of one oxygen is -2, then what will be the oxidation number of 4 oxygen atom? Go back to the maths class of first standard. If the cost of one chocolate is 5 rupees, what will be the cost of 10 chocolates? 10 into 5, isn't it? Same thing here. If the oxidation number of one oxygen atom is -2, what will be the oxidation number of 4? 4 into -2, that is -8 is equal to. So in the last class I have told you that if we want to check that the oxidation numbers, what we have found out is correct, what is the best method? The sum should be 0, isn't it? The sum of all the oxidation numbers should be equal to 0, isn't it? So I am writing 0 equals 0. Okay. Now, plus 2 and minus 8. What is it? Plus 2, opposite sign. When opposite sign comes, what happens? You have to subtract it and put the sign of the bigger number. Isn't it? That's what you have studied. Now, plus 2 and minus 8 is minus 6. Minus 6 plus x is equal to 0. Therefore, x is equal to, when minus 6 is going to the opposite side of the equation, it becomes plus 6. Okay, so the oxidation number of sulfur is minus 6. Now, as we have found out that the oxidation number of sulfur is minus 6, we have to find out whether everything, when we add everything, we should get 0, isn't it? So I am going to just repeat plus 2, minus, plus 6 and minus 6. Okay, this is the oxidation number. This one is hydrogen, this one sulfur, this one oxygen. Now I am going to find out whether the oxidation number I have found out is right. Now plus 2 plus 6. 2 plus 6, 8. 8 minus 8, 0. Okay, so my calculations are correct. So this is the way how we are finding out the oxidation number. Now we are going to find out some more. Okay, the next example. Find out the oxidation number of manganese in potassium permanganate, KMnO4. Find out the oxidation number of manganese in KMnO4. Here in the question, the oxidation number of potassium and oxygen is given. So it is easy for us to find out. Okay. Now, first step, let the oxidation number of manganese be X. And that's what we have to find out. So we are giving that X to X signal to. Okay. Now potassium. What is the oxidation number? Plus 1. Since it is only one potassium atom, no confusion. Plus 1. Plus manganese. Don't know. X plus. Here also the same property. Oxygen atom. The oxidation number of one oxygen atom is minus 2. So what will be the oxidation number of 4 oxygen atom? 4 into minus 2 minus 8 is equal to 0. Now plus 1 and minus 8. What? Subtract it and put the sign of the bigger number. Minus 7 plus x is equal to 0. Therefore, x is equal to, when this minus 7 goes to the opposite side, what happens? It becomes plus 7. So, the oxidation number of manganese is 7 plus 7. Now, there is one more part. We have to check whether what we have found out is right. Okay, so I am writing the oxidation number of potassium plus 1, manganese and I found out plus 7 and minus 8. Isn't it? Now 7 plus 1, 8. 8 minus 8, 8 is correct. So this is the way we can check whether the oxidation number what we have found out is right or not. There are a few more examples here. Here we are going to find out the oxidation number of manganese in 3 conditions: MnO2, Mn2O3 and Mn2O7. In these 3 things we are going to find out the oxidation number of manganese. Okay, so we will start with the first one. MnO2. Okay, so oxidation number of oxygen is always minus 2, so no worries. Okay, so MnO2. Okay, listen carefully. Mn2. I am putting X here. Okay, now let the oxidation number of manganese be X. What about oxygen? Minus 2. X plus minus 2 into 2 minus 4 is equal to 0. Therefore, X is equal to minus 4. It goes to the opposite side. It becomes 0 plus 4. That is plus. Okay. It is plus 4. So, in Second one, the question is Mn2O3. Okay. And we want to find out the oxidation number of manganese here. Okay. So manganese, I am putting oxygen minus. Now here there are, in the other examples which we discussed, there was only one manganese atom. But here you can see there are two manganese atoms. Okay, so when two manganese atoms come, don't be afraid, no problem. Just multiply 2 into x. You get 2x plus minus 2 into 3 minus 6. 2 3s are 6, isn't it? Minus is equal to 0. Okay, now 2x is equal to minus 6 goes to this side. So what happens? It becomes 6. 0 plus 6. That is 6. Therefore, x is equal to, when this 2x means, you know, it is 2 into x, right? Now when this multiplication sign goes to the opposite side of the equation side. Okay, opposite side like a multiplication. Entire mark, it's division item mark. Okay, 6 divided by, you will get positive. അപ്പോൾ എപ്പോഴും ആലോചിക്കേണ്ട ഒരു കാര്യം, നിങ്ങൾ ഇതൊക്കെ മാത്സിൽ പഠിക്കുന്നതാണ്, സിമ്പിൾ ഇക്വേഷൻ ആണ് കാര്യം. ഈ സൈൻ കറക്റ്റ് ആയിട്ട് ഇടണം. ഈ -6നെ നമ്മൾ ഈ ഓപ്പോസിറ്റ് സൈഡിലേക്ക് കൊണ്ടുപോകുമ്പോൾ അതിന്റെ സൈൻ മാറും എന്നുള്ള ഒരു ഓർമ്മ നമ്മുടെ മനസ്സിൽ എപ്പോഴും ഉണ്ടായിരിക്കണം. അപ്പോൾ -6 ഓപ്പോസിറ്റ് സൈഡിൽ പോകുമ്പോൾ അത് +6 ആയിട്ട് മാറും. അതേപോലെ 2x, ഇവിടെ 2x എന്ന് പറയുന്നത് എന്താണ്? 2 into x എന്നാണ് അർത്ഥം. അപ്പോൾ ആ ഇൻറ്റു എന്ന് പറയുന്ന സംഭവം ഇതിനെ നമ്മൾ ഇക്വേഷൻ ഓപ്പോസിറ്റ് സൈഡിലേക്ക് കൊണ്ടുപോകുമ്പോൾ എന്തായിട്ട് മാറും? ഡിവിഷൻ ആയിട്ട് മാറും. ഓക്കെ, അപ്പോൾ 6 divided by 2 plus 4. Now the last thing, what is the last thing we have to do? Equation correct, നമ്മൾ കണ്ടുപിടിച്ചത് കറക്റ്റ് ആണോ എന്ന് നോക്കണം. അപ്പം now we have manganese plus 3, isn't it? Okay, now I'm going to check. 3 2s are 6 plus 3 into minus 2 minus 6, 0. It is correct. Okay, then next one. Last one is Mn2O7. Here also I am putting x here and minus 2 here. Okay. So 2 into x, 2x minus 7 into minus 2. 7 2s are 14. Minus 14 is equal to 0. 2x is equal to minus 14 is going to the opposite side. Plus 14. Therefore, x is equal to, when this 2 goes to the opposite side, what happens? 14 divided by 2, that is 7. Plus 7. Okay? Here, now you can write the oxidation number as plus 7. Check it. 7 2s are 14. Minus 2 into 7, minus 14. Okay? So these are some examples by which we can find out the oxidation numbers of manganese in different compounds. Okay, so these things are very important in your future chemistry classes also. When you go to higher classes also, finding these oxidation numbers are very, very important, because when you're studying about different elements, sometimes the oxidation numbers won't be given. So if somebody asks you to find out the oxidation number, use this method and find out. So try to do, when you are practicing it at your home, try to find out more questions and practice it. Okay, so that's all for this week. Thank you.